Okay, so in today's video we're going to look at how to take derivatives of various functions. You'll see those first functions right there are our four major trig functions. We don't worry about derivatives of cosecants and cotangents in the BC Calculus curriculum. Then we have the derivative of natural log of x, e to the x, and some value a to the x. Interesting thing about that bottom equation right there is that when you apply this rule to e to the x, you just end up getting e to the x times natural log of e. Natural log of e is 1, so you just end up with the derivative for e to the x right there. So let's look at how we can apply some of these to solve some derivatives. So let's give this one a shot right here. So what I would suggest doing is, again, try to evaluate this derivative, pause the video, and then check and see how you did. Okay, well, if you've tried to evaluate this derivative, we need to recognize three things when we look at it. The first of which is that we will need to utilize the derivative of sine of x. The second, we will need to utilize the derivative of natural log of x. And the third, we have two functions right here, so we're going to need to use the product rule. So if you didn't recognize that you would need to product rule, again, pause the video knowing that you need to use the product rule and try to solve the derivative. Alright, so if you guys give this one a shot, we should get a solution that looks like this. This first term is the derivative of natural log of x times the second, we're using the product rule. Then the first times the derivative of the second, the derivative of sine is cosine. So if you wanted to just simplify this in a minor way, you could get this thing right here. We're just bringing that 1 over x and multiplying it by the sine of x. But other than that, that would be the most simplified form. Okay, so let's try another one. So again, give this one a look, give it a shot, pause the video, let's see how you do. Alright, so if you give this one a try, again, you'll need to recognize three things. First, we'll need to use the derivative of tangent. Next, we'll need to use the derivative of e to the x. And third, we have a quotient. We have a top function and a bottom function, so we're going to need to use the quotient rule here. If you didn't know you needed to use the quotient rule, pause the video and try to solve the problem again. Alright, if you go over this solution, we'll get something that looks like this. So this is just using the quotient rule. Secant squared is the derivative of that top function right there times the bottom function. Then we have minus the top function times the derivative of the bottom. Realize that the derivative of e to the x is just e to the x. That's why that doesn't change. And then we have the bottom function squared down here. Now, you can simplify this knowing, first of all, that e to the x squared is the same as e to the 2x. Also, some useful things to know is that secant squared of x is 1 over cosine squared of x, and tangent of x is sine of x over cosine of x. So knowing all these things and doing a little bit of solving for lowest common denominator, you can get to this most simplified form of the equation right here. Now, in terms of just the calculus aspects, if you could have gotten to this, that is absolutely the most important step. The simplification stuff, that's more like algebra, and that kind of stuff will come. But really the most important thing is, could you get to that first step of solving the derivative right there? All right, so let's try one more example problem. So now give this one a look and give that a shot. Pause the video. Okay, so if you tried this one, there's several things we got to recognize. First of all, we're going to need to use the product rule for two separate equations. Second of all, we're going to need to utilize the derivative of secant of x. We're also going to need to utilize the derivative of cosine of x. And we're going to need to use this derivative right here for 2 to the x. All right? So if you didn't recognize you're going to need to use all those things, again, pause the video again, try to work it out on your own. All right, so if you're giving this one a shot, we'll get a solution that looks like this. 2 is the derivative of the first function right here, multiplied by secant of x, the second function. That's just the product rule. Then we keep the first function the same, 2x, and secant x tangent x is the derivative of secant of x. So that's basically the derivative of just this first part right here. Now we're going to do the derivative of this second part. So that'll be 2 to the x log 2. That's the derivative of 2 to the x. Then we will have just cosine x by itself. then we keep 2 to the x by itself, but the derivative of cosine is minus sine, so that's why we have that minus sign out front. And with this one, I mean, we could do some simplification with the secants and everything in here, but that would just get nasty. Basically, if you could have gotten to this derivative applying the product rule on 2 different products and then utilizing the correct derivatives, you would have gotten it. Okay, so that's it. You know, we'll do several more examples using this stuff in class. But come to class with questions. In the next video, we'll look at how we take the derivatives of inverse functions.